So we're talking about Euler's method here. And what's nice is when I do Euler's method, I redo everything we've done so far. I'll do a separable equation. I'll put it on a slope field, right? We know what a slope field is. We'll look at the general solutions. We'll look at an initial value solution. And then what's the thing that we're trying to do with Euler's method is how do you make a prediction, a future value prediction, given an initial value problem that can't be solved, right? So given an initial value problem, oops, how do you spell? I-N-I-T-I-A-L, initial value problem. Let's say y of 0 is 1, right? How do you find a future value? Right, like y of 1. And that's typically what I do on every question, every test. I give you a 0, 1, and then ask you to find y of 1. Right? I give you y of 0 is 1. What's y of 1? And so we were working on a problem the other day. Let's change it just a little bit, right? And see what happens here. So let's say y prime is equal to xy, right? And that 0, 1, y of 0 equals 1. So that gives us, so we have an initial value problem, right? This thing alone, it will give me a general solution, meaning I'm going to have some constant of integration. And then this thing will give me an ability to solve for that constant and then give me one curve instead of a family of curves, right? So so let's go with what we know already, right? Let's go with what we know already. So let's think about the slope field first, right? So why don't we get all of our let's get 0, 0, let's get 1, 1, let's get 2, 2, let's get to ballerina point, let's get 3, 3, right? Minus 1, minus 1. Let's get that diagonal. What do you get for that diagonal? What do you get for that diagonal? What kind of slope's there? Well, at 0, 0, what do I get? X times y is 0 times 0. That's 0. So I get a slope of 0 there. I get a horizontal line there. In fact, whenever x is 0 or y is 0, I get horizontals, right? My slope fields anywhere on the axis are going to be zeros. Is that making sense? Does that make sense to everybody?
Yes.
And if it doesn't, of course, you're going right away to GeoGebra slope fields. I think it was it Phelps? Steve Phelps was I using yesterday? I think that's what I think I just remember it now. That's what I was using last semester. So I'm going to GeoGebra. You can see my screen, I think. GeoGebra.org. Yes, it's in my bookmarks because I'm a nerd. And I hit the search button and I do a slope field. And it's Phelps that I liked. I don't know if that was there yesterday or if I just missed it or I picked someone else that looked like it. But here's my slope field, right? And what did I have? I had x, y, right? And you can see all the horizontals on my x-axis and all the horizontals on my y-axis. So those are the 0, 0 slopes. Slightly different than the one we were doing yesterday. If you remember, the one we did yesterday had a parabola like at the top, parabola at the bottom, sideways parabola at the right, sideways parabola at the left. This one is almost only parabolic everywhere. It's not quite a parabola, but it's close. How we doing here? You comfortable with this? So look at my slope field at XX or YY, right? 0, 0, 1, 1, 2, 2, 3, 3. What am I getting there? What am I getting on that diagonal? At 0, 0, I get 0. At 1, 1, I get 1. At 2, 2, I get 4. At 3, 3, I get 9. Right? You can see, so I'm getting this kind of curve going up here, and that's really that shape I'm seeing there in my initial value solution. You can see they're kind of like blockers for the water, or like if I'm looking above, right? It's Plinko, I guess, if I'm thinking of like dropping the little steel ball and it's bouncing around on the things, right? It's an old game, I guess you wouldn't know it. What's the one now? Some stupid game where they're dropping, they have a giant wall and the balls are falling down and hitting things and they go into the money slots at the end. What's that stupid game? Like Jamie Foxx was the host or something. You're too old to watch TV. I mean, too young to watch TV. I know that. But they keep redoing that same stupid game over and over. But it's just a bunch of slope fields all kind of bouncing it one way or the other, 50-50. It's a famous stat problem. Okay, so we understand the slope field is very easy. I'm not going to ask you to do a slope field, but I would give you a slope field on a test on the final and say, do a rough draft of your initial value solution on the slope field, right? And so you would graph it on your calculator and you'd try and fit it in your slope field. And if it didn't fit in your slope field, you knew you had it wrong. Right? If the slope field was all like going along a diagonal and you had some kind of crazy curve, it should make sense. It should fit in the slope field. Good. So let's do the separable here. So let's find the general solutions. So y prime equals xy. First thing we do is change our y prime into dy dx. And I'm thinking I have a separable equation because, and you say in unison in the class out loud,
well, you can separate the x's and the y's. So
separate them by multiplication or division, right? So you have some kind of multiplication, you have some kind of division. And you'll see when we have addition and subtraction today, that's when we use a u sub. It makes it a little bit more difficult. But so what do I get here? I get 1 over y dy equals x dx. Is everybody comfortable with this? Anybody not comfortable? All right, Nima, you're okay. Thank you. Nima, sorry. David, thank you for putting that there. So no one had to type it or search for it. Thank you. The GeoGebra. That's the Phelps one, is it? David?
Yes, that's the Phelps one.
Thank you. So now we're going to integrate. Right? We're going to integrate. And so what do I get? I get ln of y, absolute value of y equals x squared over 2 plus c. I want to get rid of this ln of y, right? So I'm going to raise both sides base e. So I get absolute value of y equals e to the x squared over 2 plus c. And it's usually around this point that I would try and do something with that. C, absolute value of y, in the book is generally doing e to the c times e to the x squared over 2. Right? Because when you're multiplying like bases, you're adding exponents. So if you're adding exponents, you could change it into multiplying like bases. And then finally, the y is plus or minus e to the c, e to the x squared over 2. And then at that point, the book will say y equals k e to the x squared over 2. So just trying to simplify it as much as I can. K is some real number. Could be positive, could be negative. Unlikely it's 0. No, not true. Could be 0, right? Because x times y equals 0 could certainly be but the solution is 0, right? If I have an initial value of 0, 0, right? Sorry. If I have an initial value of 0, 0, you can see it just hits my horizontal line at 0, right? How are we doing on that? That's right. We did a good chunk of 7-3 yesterday, just because I hate waiting to give you the how do you solve a problem. I hate waiting to show you how to solve a problem. This is my general solution. How do I find my initial value solution now? I'm going to plug in y of 0 is 1, right? And yeah, I tend to keep it like that just to make it easy. So when I plug in y is 1 and I plug in x is 0, I get k as 1. So it would take care of my plus minus for me. So even though I've hidden that plus minus e to the c in there, when I plug in my initial value, I'll know if it's a positive or negative. So my initial value solution is just e to the x squared over 2, which is nice. Kind of cool that you can see a parabola in there, right? You see the shape is kind of parabolic. It's not. It's more hyperbolic trig. So when you engineers will be taking the DiffEqs, you'll look at hyperbolic trig functions. And the hyperbolics are famous for, like if the Brooklyn Bridge, right? Brooklyn Bridge, I got these two support systems and I hang a chain on it. It looks like a parabola, but it's not. It's called a hyperbolic trig. And so it's some kind of like cosh of theta, which is hyperbolic cosine, which is just some connection of e to the x and e to the negative x over some number. So, but you'll do all of that in the Calc 3 class. I'm sorry, in the DiffEqs class. So we did everything from yesterday. We looked at the slope field. We found a general solution to and an initial value problem to a separable equation. What do we want to do? We want to graph this e to the x squared over 2 on our calculators to make sure it fits into our slope curve, right? So I'm just using GeoGebra here. You can use your, I'm sorry, I'm using Desmos. But you can use your calculator. It's just so much easier for me to demonstrate on this than on the calculator. But if you do have calculator questions, you can certainly ask me those, right? And so I had y equals e raised to the x squared divided by 2. And there it is. So it seems to fit into the grooves of my slope field. So sometimes we can't solve these DiffEqs. Sometimes we can't solve integrals, but they still could be viable, right? So our question is now, we're getting closer to Euler's method here. Our question is, right, if y of 0 is 1 and y equals e to the minus x squared over 2, right, find y of 1. Easy, right? Y of 1 is simply e to the minus 1 squared over 2, which is e to the minus 1/2, which is 1 over square root of e. And that, of course, is, I can get an approximate value of that. Where's my calculator? About 0.6065306597 or 0.6065, right? I think our GeoGebra for Euler's method will give us 4 decimals or more, or even we could even control it. So, but in this particular situation we're talking about, we've got the problem, we've got the initial value, but we can't find the solution. So we're going to estimate it using Euler's method. So, and this is where we kind of left off yesterday. How are we doing though? We're okay here at this point? This is chapter 7, usually one question on the final. So not much. It's only 3 sections. The rest of it is bio applications. So I do have several bio students in here, and that's where I was thinking about taking a second bio project component from, but I still haven't made a decision on that yet. Any of you going to be bioengineers? Any of my bio students thinking about biomath? And I'm not offended if you say no or just laugh at me. Any bio students thinking about Saran has got the tears coming out. No one's thinking about bioengineering or biomath. That's fine, but you'll have someone on your team. You know, you go work for some company or some healthcare system, or you know, some cure for cancer place. You'll have a biomathematician on your team, and they're going to be doing all these diffie-Qs on your projects to try and predict values. So here we go, Euler's method. So given y of 0 equals 1, predict y of 1 using, now I'm going to put the book's version down and I'm going to put my version down. I like my version, but you know, whatever you're comfortable with. I think you really have to come up with your own version to really make sure you get yourself to understand. So this is in 7.2, Euler's method. We've almost done everything from 7.3. We have to do 2 things more from 7.3. This is our last thing from 7.2. It says y prime is capital F of xy. So like in our case, in the previous problem, we had what? Y prime is x times y. Right, so f of x comma y is x times y. Our initial value is x sub 0 plugged in, and I get y sub 0 out. So when I plugged in 0, I got 1 out. And I'm going to use a step size, or a delta x, of h. Right? So it's really kind of a delta x, right? So if you look at where I started and where I'm going to, I started at 0, I'm going to 1. If I only do 2 steps, I'm going to cut 0 to 1 in half and go halfway and then all the way. If I do 4 steps, I'm going to cut it into 4. So it's just like a delta x piece, right? Right? So, and then x next. So x sub n is x sub n minus 1 plus h. I like to say x next is x plus h. Just take the previous x and add h. So if I had a step size of 1/2, I'm doing 0 to 1/2 to 2/2 to 3/2 to 4/2, just like a delta x, right? So I really like to think of this piece as delta x, right? So this is the book. And this is for us, right? And then finally I get y sub n is y sub n minus 1 plus h times f of x sub n minus 1 comma y sub n minus 1. Yes, it's horrible. for n equals 1, 2, 3, a bunch of steps, right? I try to do 4 again because I lose patience after. I only saw 4 patients today. Get the rest out of the rating room. I don't want to see anymore. I like y next is equal to y plus h y prime. So that's my version, a little bit simpler. So very abstract. It's like I'm giving you directions on how to get to, oh God, somewhere horrible. Lake Manassas in Virginia, okay? Oh, horrible. And so it's horrible, but you can't think about the whole thing. You got to think about one step. Okay, get on 495 going toward Virginia, right? That's it. That's your first step, right? So for some of us, that means get on 270 south. For some of us, it means 95, right? But anyway, you know what I'm saying. This is a horrible set of directions here. I think if you see my process on this side, you'll see it's a lot simpler. And then I'm going to show you on GeoGebra. Okay. So our xy, right, and our n. So step. This is my step, right? And these are my xy's. I started when x was 0 and y was 1, right? And I want to figure out what happens when x is 1. That's my goal. And I'm telling you I'm going to do it in 4 steps. I'm going to typically do it in 4 steps if I do it to you at all. Okay? Yes, you with me? Good. So I need to figure out h. How do I get from 0 to 1 in 4 steps? Well, I got to go by a quarter, right? $1. $0 to $1, it goes by quarters, right? So again, delta x here is 1 minus 0 divided by 4. That's 1/4. That's my h, right? So I can already see I'm going to go 0.25, 0.5, 0.75. That easy, right? Does that make sense? Everyone with me there? Just like a delta x, right? Anyone with me there? Charlie said yes. Eleanor said yes. David said yes. They have their camera on. Adam said yes. Angel said yes. Charlene said yes. Thank you. Juan said yes. So now I'm going to use my y next. Thank you, Aruz too. Aruz and Juan, thank you. So now I'm going to use my y next formula. So look, x next is taken care of. What do I do to get the next x? I just keep adding h, right? So I went from 0, add a quarter, I get to a quarter. I go from the quarter, add h again, I get to 0.5. So x next, I think this formula should make it pretty easy. Just keep adding h as you move, right? I'm going to try and explain what's going on graphically too, okay? So let's get our y next now, right? My y next formula says take the previous x, which was 0, and multiply by h, which was 0.25, right, 1/4, times x times y, right, times my y prime. Let me do a general y next first. Y next is y plus h times xy, right? That's my y prime, x times y. So that's what 0 times 1. So I get 0. Zero times 1 there, sorry. Right, so I just get 0 again. So there's my y next. So I put my y next in, and I rinse and repeat, right? So now I'm doing line 2, right? This is n equals 1. Now I'm doing n equals 2. What's my y next now? Well, my x next is done, right? It's 0.5. But what's my y next? I start with a 0, and I do 1/4 of 0.5. I guess this was not a good 0.5 times my previous y, which is 0. I get 0 again. I'm gonna be stuck now at 0. So I'm gonna get 0 every time. I can already see the prediction. But so this was just a bad example on my part. But let's go to GeoGebra for a second, and we'll do a better example. So GeoGebra, but I'm going to search for Euler's method, Euler's method. Right? So if I go back to home and I search for this one, I think I like the Juan Carlos. So David, if you do that link again for me, that would be great. Euler's method. David will put the link into the chat box. And this one I like the Juan Carlos. Pretty sure it's Juan Carlos. Where is he? There he is. David, will you send that to everybody for me?
Yes.
Thank you. So in this one, you can see I can set everything. So I want to set it to mine. Make sure I did it.
You're not on share screen right now.
Oh, thanks. Oh my God, I did all of that without being on share screen and no one told me? Damn it.
No, you've been on it, and then just when you went back to GeoGebra.
Oh, okay.
No, we're not that bad.
Okay.
Just
My God.
Oh.
Like I'm yelling all of these numbers and calculations. I'm like, oh my God. Okay. So you can see my screen now here. There could be a better one. It's just I'm ADD, so if I find something that works, I don't keep looking. Okay. But there's no reason for you not to feel like you should explore and see if there's a better one out there. So I had my differential equation was x times y, and I had started at 0, 1. So that's all set, right? X sub 0 is 0. I started at 0, 1. There's my initial value. And then I did an h value of 0.25. And obviously I made a mistake when I did my calculations, so I should have gotten to there. So let me look at my calculations again. I made a mistake somewhere. Sorry. Thank you. David just sent that link out. So try and get that table set up, and let's see if we can get back to this solution. I made a mistake somewhere. I didn't want to. Trust me, I did not want to.
I think the initial value of y was supposed to be 1, not 0.
There, that's my mistake. So when I did, but the initial value of x was 0. Oh, yes, so I should have had a 1 here. You're right. Thank you. That saves me. So let me do it over, okay? Let me do it over. Let me save face. Let's pretend I didn't record all of that. So sorry. So x next, obvious, I think, right? Just keep adding that 0.25 every time. Y next, a little bit slower, Robert. What do I need first? I need the y before. So that's 1. There's where my mistake was. Thank you. Plus the 0.25 times x times y. X times y is 0 times 1. Notice that the 0 and the 1 are going in here, right? They're from my previous line. So I get y next is 1. So now I'm putting in that in the next line. I got my y next. For step 1, for n equals 1, for the first time I calculated, I'm getting a value of 1. And now I rinse and repeat, right? So for n is 2. Is everybody with me there? Is anyone with me there? Saran is there. Adam is there. Charlie rolled his eyes at me. He's there. Name is there. Ash is there. Thank you. Thank you, Haoshin. Charlene, thank you. Okay, so let me keep going now. My next y value. So y next now. My previous one. Now look at where I'm doing. This is my previous line now, right? X is 0.25 and y is 1. So y is 1 is my previous y. H is still 0.25. X is 0.25. And the y is 1. So I've got, oops, this is a plus. I've got 1 plus 1/16, right? And that in a decent decimal. .0625. Now this is the key, is looking at Euler's method here. Look at my next value for y. That's exactly what I just got, 1.0625. So could you imagine having to do this by hand? No. And so it's typically not on my exam. So the problem you saw me do today before Euler's method is the one that's on my exam. Here's a separable equation. Here's the slope field that fits it. Find me the general equation. Find me the initial value equation. Give me a rough draft of the initial value solution on the slope field. That's the question I usually put on the test. But it's important that you see this process, because this is the process that's more likely happening in the real world. We can't always find solutions, but doesn't mean they're not plausible, right? We can't always find this a perfect, nice little equation, but it doesn't mean that a solution doesn't exist, right? So let me try and explain. Do you want me to do another, or how are we doing? We okay? Another step?
Yes, please.
Yep. So for n is 3, I'm using the 0.5 for x and the 1.0625 for the y, right? Because if you can see, that's what I have for my next line here in green. 0.5 and 1.0625. So y next for me is 1.0625 plus h times the 0.5 times the 1.0625. And I get 1.1953125. And I think my table on GeoGebra is probably going to give me 1.1953. Maybe it'll give me 5 decimal places, I forget. It gave me 4 decimal places. So you can see I can make my prediction of 1 and 1.4194, right? I can see that my prediction for y sub 1 is approximately 1.4194. Right, and what did I get for y of 1? I got 1 over e, square root of e, right? Which was 0.6065. Now, not very good, but four partitions. And you can see on my Juan Carlos app, you can see that with an h value of 0.25, there's the initial value, right? And there is my approximation. So it looks like I have something else wrong, but let me just double check that. Good, Robert. where did I get my value? It's not looking too good there. I don't know where my mistake is, but it's okay. So, yes.
Could it have been e to the x squared over 2, not negative x squared over 2?
That does sound like it would get me closer to it. Let me just double check that. Thank you.
Yeah, that would have been...
Oh, you're right. It's x squared over 2.
The integral.
Yeah, when I wrote it on the next page, I put a negative in there. Thank you. So y of 1 should have been e to the 1/2, right? Or square root of e, which is approximately, thank you, Robert. Second square root of e is 1.6, yes, thank you. 1.64872171, so about 1.6487. Okay, so 1.4 compared to 1.6 is not great, but n is 4 is a delta x of 0.25. When we're doing calculus, we're doing delta x's that are infinitely small, right? We're going to delta x is nearly 0, right? And so that's what we want to look at. How good does this get? So now we know the real answer, 1.6, right? How good does this get if maybe we do h is 0.1? So it takes me 10 steps to get there, right? If h is 0.1, look now, I'm at 1.54, okay? But 0.1 is not very small. It's a dime compared to a dollar, right? A penny would be better, but how many steps would it take? It would take 100 steps, right? But of course, we're doing all of this on a computer. It's going to be very fast. In fact, there's one on your homework where you're going to have to use Excel to do it. And so I'm going to do the same one on Excel right now. Now look at my purple line is my initial value solution. Look at the blue line with the estimates. See how much closer it is now if I use an h as 0.1, right? And so guess what this thing is doing? It's actually walking out delta x and out delta y, and then that's the tangent line. So it's building tangent lines along this curve, and that's what's estimating the thing. So it's way back to tangent lines from Calc 1 is Euler's method. And Euler was after Newton, so Euler was using the calculus just to figure out how to solve these systems and its equations. Let me build one on Excel, okay? And if you can open Excel and do this with me, it will help. You need to do it in your homework, okay? So I'm just grabbing a blank Excel page. And of course you could do it on, what is it, charts is the, right? So I'm doing N, I'm doing X, and I'm doing Y, right? And so my initial step is 0. I didn't do anything yet. My X was 0, my Y was 1. And for N, I'm going to do the previous. So I'm going to say cell A2 plus 1. Right, and so it's just going to, and then I can fill down, so I can do a quick number of steps with Control D. So there's 19 steps right now. Does anybody need me to do that over, or say that a little slower, or? For X, I want to add H every time. So I'm going to do, in the next cell, equals B2, right? Capital B2 is the previous cell. And I'm going to add H every time, which we said now is going to be, let's just do a penny, right? 0.01. That's what you're going to have to do in your homework. So notice now, if I grab that cell and fill down, I'm counting by a penny there. Control D fills down, so 1 cent, 2 cent, 3 cent, 4 cent. Is anyone doing this with me? Can you see a thumbs up or a nod? Is anyone doing this with me?
Trying to set up Excel.
Okay, I can start back once you're there. Anyone else trying to do this with me? Open Excel. No one else? Okay. So
there's an Excel option on Montgomery College if you go into your email.
Correct. You should have the Microsoft Office for free. You certainly can use the Google spreadsheet. I think is it called Charts? Or is it called, what's it called? The Google Docs?
Google Sheets.
Sheets.
Yeah, wait, would that work?
Yeah, it works. Same way.
Okay.
So in I've got columns N, X, and Y, just like on my paper, right? And N is just the number of steps. So my initial start, there's no step. I didn't do anything. I had an initial value of 0, 1. So my first line is N is 0, X is 0, Y is 1. And then I'm just adding 1. So to get that next cell there, you see I put in equals A2 plus 1. So I'm just adding 1 to the previous cell. And then I keep doing that. A3 plus 1, A4 plus 1. I just keep adding 1 to the previous cell. And for X, I just add H to the previous cell. So it started at 0, and then I took the previous cell, added 0.01. And then took the previous cell, added 0.01. Previous cell took the, right? And so for the next one, though, I'm doing Y next, right? And so I've got to do the previous Y, which is C2, plus H 0.01 times the previous X, which is B2, times the previous Y, which is C2. And then that's going to give me my next few values. Right? So, and then I'm going by penny from 0 to 1, so I want to do 100 steps. So I'm going to fill down 100 steps. And David, I can come back to all of this if you're not there yet. So I'm going to go down to all the way to line 101. So I'm just holding my shift key down with those 3 columns highlighted, going down to 101 and then Control D. And when I finally get there, whoops, I need a 102, sorry. So step 100, Control D. I finally get there, 1.63. Not perfect, but close, right? Not perfect, but close. So I'm pretty sure that Sheets references the rows the same way. And then you can do the same thing on Sheets. I think Control D will also work on Sheets. I don't quite remember. It might be you have to go fill down in the menu. I'm not sure. Haven't used it in a while. David, what you need? Anything?
Just trying to go in. Just having technical difficulties.
Opening the program.
Mm-hmm.
Yeah.
I still had GeoGebra, so my computer went crazy.
Yeah. I told you. It's constantly running a script. It's just a JavaScript, but it still takes memory.
So when you just typed in like A2 or B2.
Yeah, and I had to always say equals. If I'm starting the line, I have to say equals for it to do a calculation. And then I reference the cell with A2 or B2 or C2, and then do some calculation with it, right? So if you can see there, my first line in N is take the previous step and add 1 to it. Right, so take the 0 above and add 1 to it, and I get step 1. For my x's, my first x is 0, but to get my next x, I have to add h. So I say, okay, take the previous x, which is b2, so equals b2 plus the h value, plus 0.01. And that, go ahead. And then the y is the complicated one, but it's that y next formula I gave you. So it should be take the previous y plus h times the previous x times the previous y. And so there I'm referencing C2 as my previous y and B2 as my previous x. And then the control D will fill everything down. So there's one problem in WebAssign when you'll need to do 100 steps, and do it on Excel or do it on Sheets. You can't do it in the GeoGebra app, I found, because it will only give you 2 or 3 pages. And it's 10 steps per page, so it'll only get you up to step 30. And there's maybe another one, and I've looked, but I can't seem to find one, but maybe you can find one on GeoGebra that would just give you a prediction value without showing you the chart. But I think the chart is valuable if you're going to try and do 1 or 2 calculations on your own.
How do I input into Excel now? So I have 0.
Yeah, so you've got a blank.
And export.
Yeah, you've got a blank page open, and you've got your initial row in of 0, 0, and 1. And then your very next row, is that row 3 for you, or are you in row 2 now?
Row 3.
Okay, so
I have 0.
So you want to type exactly what I have, equals A2 plus 1. So you're going to add 1 to the previous cell. So equals A2 plus 1. And then hit enter, and you should see 1 now in that cell. Success?
Yes.
Good. Now in B3, we want to add h to our previous x. And I said h was going to be 0.01 for us. It will be in that homework. So we're saying equals B2 plus 0.01. And then you should see that moving by a penny. And so the easiest thing now is to highlight that last row, right? So I moused over it, put my shift key down, I've highlighted those 2, and then I highlight down and hit Control D, and it should fill down a bunch of steps and a bunch of x values for you. And then you can see in my, I don't know if David, tell me if you're not there yet, but I'm highlighting C3 now, which is my y next formula. So equals C2, which is my previous y, plus h times the previous x times the previous y. And then I fill down everything for 100 times, and I get finally my prediction value. How'd you do?
So I'm having trouble inputting, I guess, B2 or.
Yeah, equals B2, right? Equals B2 plus 0.01.
Equals B2.
Equals B2. And I don't know if you can see it here on my page. I've got it highlighted. So in cell B3, I'm writing equals B2 plus 0.01.
Okay, and the C value will be...
Yeah, that one. So C3 row is, oops, sorry. My C3 row is, oops. Get out of there. My C3 row is equals C2 plus 0.01 times B2 times C2.
0.0.
The rest of you will be asking me about how to do this next week. So try and look at the video first before you all ask me again next week. Okay.
So C3 equals C2 plus 0.01 times B2 times C2.
Correct. And then after you get that row 3 done, I'm just highlighting that row 3 and then highlighting down, holding the shift key, and then Control D will fill out the whole thing. Right? So Control D will get me prediction values later on.
Okay.
Nice. Now, what's going to change as you do this in the future? Your H value, right? So, of course, the computer scientists are all angry at me the way I did this sheet, but I just wanted to do it quick. You should have a reference to H somewhere else, of course, and probably a reference to the differential equation somewhere else, and then call all of them to program your X next and your Y next. I agree. So, but this is just a simple way to do it. But of course, I'm going to have to change my H value eventually. As I do another problem, I'm going to have to change the differential equation value as well, right? This one was an X times Y, right? So, and I have that written hard-coded in. I have X times Y hard-coded in. And of course, computer scientists are all grumbling right now. Why are you doing it that way? You should do it this way. And I agree with you. Someone could send me a nice Excel spreadsheet of Euler's method done with better accuracy and precision and simplicity when programming, right? Maybe Charlie would do that, or Melky will do that. Melky, you're a computer scientist, right?
Yeah.
Yep. Michael's electrical engineering. Josh is mechanical, right? Josh is asleep. Yeah, Josh is mechanical. Yeah. Niant's bio, Caleb's bio, right? Ash is physics. Charlene, what was it again? Computer science?
It's biology.
Oh, bio. Sorry, Charlene. Sorry. I'm sorry. I'm not remembering everyone. I have it written down, but I'm trying not to cheat. Just like when I can't think of something, I try not to look at my phone. I try and just remember. It's usually bad. All right. So there's Euler's method. You got a couple to try in WebAssign. I don't need to give you more in the book, because if you can do the ones on WebAssign, you can do it. And I'm not going to test on it. Why am I not testing on it? Because it doesn't make any sense to do it by hand. Right? So how am I going to have you do it on the test? So, but it's good to see it. Okay. And David, they mentioned it by name in the movie, did they?
Yes.
Yes.
By name.
Yes. Yep.
Big scene.
Yep. When they're trying to solve this one problem, right? They can't solve this one problem, and then I guess the lead guy goes, "Well, did you try this method?" Right, or something.
Yeah.
I kind of remember that. Yeah.
Yeah, they're like, we need new math, and
oh no,
we don't have
the
math
woman,
to do this.
the woman, the what they call her? They called them calculators, right? Is that right? Has anybody else seen the movie? So these these women that were doing all of the math behind the scenes, black women in the 50s and 60s, right? Awesome. Just because I'm just saying that doesn't mean they couldn't do it. Of course they could do it, but they were not given opportunities, right? Women even were not given such opportunities. So then they're doing these calculations, and they're all trying to figure out this thing, and the one woman goes, I think I can do it with this stuff we did in grad school. And she came up with a solution, which is just awesome. I got a funny message from Caleb. Hope he doesn't mind. He says, sorry, I fell asleep. I don't blame you. It's boring. This stuff's boring. All right, let's do one more thing today and then quit, okay? So we're back in 7.3 now. We've done 7.2. Go ahead, questions?
Yes. Do you mind to repeat the C columns?
No problem. In Excel, column C is my previous Y plus H times the previous X times the previous Y. So equals C2 plus 0.01 times B2 times C2. So equals C2 plus 0.01 times B2 times C2.
So I did that, but I have a different number.
Do you mind sharing your screen?
Yeah.
You do mind or you don't mind?
I don't mind.
Okay, I'm going to make you a co-host to share your screen. Okay, hold on a second, please.
All right.
Okay, you're a co-host now. You could end the whole class right now if you hit exit. So don't do that. And so you can share your screen and share, or you can share your Excel file. And then let me take a look. Okay. Beautiful. So highlight. Okay, your initial X should be 0, not 1. Your initial X. So in B2, make that a 0. Yeah, everything else looks right.
Here.
Yeah, make that a 0, and everything should change. Hit enter. There it is.
Oh, right. Okay.
Yep.
Thank you.
Now I got something different for my C4. Will you highlight C3 for me, Nema? Oh, share again and highlight C3 for me.
You say there's C3?
Yeah, highlight C3 for me, yeah. Oh, no, that's right. No, do that one more time. No, just the C3 cell. Yep, that's right. That's right. Beautiful. Nice, you got it. Good, we got, I wanted to do 2 more things, but I probably just would do one. So I want to do another separable equation, but this one is a U sub. Okay? So this should be our last problem today. I'm going to run and do some errands. I will come back if you know you're going to come see me. Send me an email. Let me know what time. Just so I can make sure I'm back for you. Okay. So we're doing separable equations. Separate with a U sub. These are in the book. So in 7.3, I will tell you, I will ask you to try a couple of these. In 7.3 in MindTap, I like 11 to 18 for my separable. Sorry, number 1 to 18. This is 7.3. And then for the u subs, it's number 21 to 24. And of course you don't have to do the odds. You can do the evens because you can check them with the slope field, right? And your calculator and that type of thing. So there's a couple of u subs to try in there. I typically put a u sub on the final. I did not last semester, just to make it a little easier. But when we get there, I'll let you know if I'm going to put a u sub on or not. Okay. But so there is the problems in MindTap to do. So let's look at the first one that we should do, which is x plus y. So y prime is x plus y. So not a product. So it doesn't look separable. It's not a product or a quotient, right? But it turns out I can do this one if I do a u sub, if I turn it into a product. Okay. And on all of the u subs, I will tell you what the u sub is to make it just a little bit easier. So it does that in the book as well. It says do this u sub, right? And so I would do that also on the test, make a u sub. And in this case, the u sub is x plus y. Okay? So this is a separable equation with a u sub. When it is a u sub, I'll tell you it's a u sub, and I'll tell you what you should pick as your u substitution. Okay, making sense there? So first of all, let's graph this diffie-q on a slope field, right? So I'm going to go into GeoGebra. I'm going to shut. Sorry, I'm going to make sure I don't have too much open here because it's going to just start to eat my memory. So I'm going to close my Desmos for sure. And I'm going to go back home on GeoGebra because if I have a script open, it's running it the whole time. Some of them are. I mean, these are mathematicians, not computer scientists. Some might be both. But the code, I'm sure, is not perfect on all of them. So I want to do a slope field again. You probably have that one bookmarked already in the chat from David. Put that there. I like the Steve Phelps. And I want to put in my differential equation of x plus y. So there it is. And let's look at a particular coordinate, right? So if we can, let's pick like maybe, it looks like 2, 2, the ballerina split part I get pretty good right there. Can you see the hand on the coordinate 2, 2? And then there's a red slope there. And so remember, it's an x plus y. So what is 2 plus 2? Slope of 4. So it's steep, right? Slope of 4 is pretty steep. Right. So you I think it's very clear what a slope field is, how to calculate it, and how to do everything. We love our initial value of 0, 1. So why go away from it now? So there's going to be our initial value solution that we're going to double check, right? So let's say y of 0 is 1. Right? So this is my diffie-q. This is my initial value. This is my u sub. All would be given to you, okay? So the trick is to start with the u sub. So if u is x plus y, let's differentiate, right? Let's do d dx of both sides, right? d dx is my operator derivative, correct? What happens on the left side? Back to implicit differentiation. What do I get for the left side?
I guess 1 plus y prime y.
Okay, so I'm differentiating in terms of x, right? So what do I get on the left side if I'm doing du dx? u prime. Sure, u prime. Or I could just leave it as du dx because that's what's I'm going to turn that into my separable piece. What do I get on the other side?
One plus dy dx.
Nice, 1 plus y prime, but y prime is x plus y, so that's really u, right? And this is the little trick. Now I have du dx equals 1 plus u. And so now you can see I've eliminated the variable y completely. So that's a subtle trick, but it happens almost the same way every time. So I get back to a y prime, and then I take that y prime and use my u sub again, right? Yes, very strange. So what do I get? I get 1 over 1 plus u du equals dx. Now it's separable. Now I've got a product on the right, right? It's the product of 1 plus u times 1, right? So now I've turned it into a product where the factors are in one variable or another. And so what do I get here? As I solve this, what do I get here? So now I'm integrating, right? Okay, I won't wait for you. ln of the absolute value of 1 plus u equals x plus c. Right? Not difficult. So I'm going to raise both sides base e. So absolute value of 1 plus u is e to the c times e to the x. So 1 plus u equals plus or minus e to the c, e to the x. And I get what is u? It's x plus y, right? So 1 plus x plus y equals k e to the x. And it looks like I'm moving the x and the 1 over. So y equals k e to the x minus x minus 1. There's my general solution. The family of solutions with values of k. K is a positive number, k is a negative number, k is 0. How are we doing here? You can't tell me it's Monday, that's why you're quiet. We used that one yesterday. Charlie's laughing. I want to find this value of k. So I know if I plug in 1 for y and 0 for x, I get, it looks like k is 2. Anybody agree with me on that? So my initial value is y equals 2 e to the x minus x plus minus x minus 1. So there's my general solution or family of solutions, and there's my initial value solution.